I don't want to take away your ability to play with the tree to start with. So I'm not going to do add to the tree for you. That's a really important, vital method function to build. But I do want to show you the fill the vector to both get used to the code and how the code works, and also to give you an idea of how to traverse a tree and how that functionality works. So if I run this right now, you can see um, I already have, as I said, done the add size and clear. I'm not going to show them to you, let you do them. But once you have those taken care of, then you can go test the toVector. And the toVector, by typing it ahead of time, you might be able to use it to help you figure out if you're adding correctly or not, why you're not working. So you'll have to work a little bit with the add, but you might be able to have this guy ready and call it to print out, as part of your debugging stuff. So the toVector approach is also going to take care of use the helper, as a lot of the methods here are going to do. So the vector itself, the toVector itself, has a very simple responsibility, the way I've defined it here. So I'm going to have this helper define the initial vector. So the vector needs to be a string vector, and I can name it whatever I want to. I like to be very literal in my naming, so return me. Name it something different if you like, is equal to a new, oops, I'm sorry, this is a pointer to a vector. I need to be able to pass it around. A new vector, which is the string, and I create a new instance of that. All right, and so this is the vector I'm gonna get out there. Return me, and even this simple code, if your add is up and running, I'll just show you how it works. Will move along. I won't see the error. It's not built anymore. But notice I have an exception. That little bit of tiny, simple little code blows up in C++ because C++ is not. I've actually given up on trying to handle exceptions in C++ because if certain types of exceptions you can't handle at all, it just kills your program. And so I'm trying to be less fancy in that. Java, great, handle lots of exceptions. C++, not so much. But we have to fill this vector to have it do something useful. All right, so all I need to do is, once I have the vector, I need to fill vector, return me for the root, the start of our structure. All right, so most of the work is going to happen not here, but down here in the fill vector. So it's a recursive call. We're going to recursively fill the vector one node at a time. So what is the base case? That's always the answer. Always the first question. What's the base case? So the base case, well, you could say the base case is a leaf, in which case I have a vector, I'm sorry, a node that exists but has no left, no right, and then I'm returning that value. But if I think of it that way, then that means I have to, deal with the fact of I could be called something that is already null. Again, I shouldn't, but I notice I didn't put a check up top to see if the root is null. So sometimes the simplest base case, and that's what you'll see in a lot of cases, is just to say if the node itself, so the subtree. Notice I call it subtree here, not root. Many cases in the book they call it root. I like the helper methods to be called subtree because it reminds me I'm not only dealing with the main tree itself. I'm dealing with a piece of the tree. So if that subtree you hand to me is equal to null, well, really I don't have anything to do. I just return. I have nothing to add. So given this strategy, it makes my life a little bit simpler because I'm dealing with every node the same way. So that's one advantage of doing it this way. So I could have said if subtree.left is equal to null and subtree.right is equal to null, then I do one thing, but I can do the same thing now that I've eliminated all null trees one way or the other. So what do I do to traverse a tree? Well, if I want them to go in numerical order or alphabetical order or whatever the order is from lowest to highest, whatever that is, then the lowest one is always the one to the left. And the highest one is always the one to the right. So I'm always the one in the middle there. So if I want to fill a vector using the lowest to highest order, then really what I want to do is I want to fill the vector for my left node. All right. Oh, I'm sorry. I need to pass in the fill me first. So I want to fill it for my left node. I'm sorry, and I need my Java's leaking out here. And then I add my value to the vector. So if I say, I'm sorry, I'm sorry, I push back first to the subtree of my value, right? So I throw all the left values in, which is really only going to be one value at a time, and then throw my value in, and then I'm going to do all my right values. So my big complicated tree with all the little different levels and nodes and lefts and rights and everything else, I can traverse it in order by using this quick, simple set of code right there. So let's see if that works. I run it, and my toVector passed. Now it doesn't show me what the toVector does. That's important, but for now I can see that my test passed in those simple bits of code. And then I move on to the contains and doesn't contain F, and it fails, and it goes on from there. But this is an important step in the middle, because if you don't get it right, you'll have an exception, it'll blow up. But then if you do get it right, it becomes a tool you can use going forward. So for instance, when I get to my contains, let's say, and I'm not sure what's going on here, I can print out that vector. So unfortunately, maybe I should. Well, yeah, no, that won't entirely work because it'll be circular. Maybe I should actually move inside of the tree set. Sorry, trees.cpp. There is a toString out here to print out a vector for you to make life a little bit simpler. I'm going to cheat for the minute. It might be. Oh heck, let's do some real-time editing here. I said I don't try and make these videos on their own. Let's say add a new item, and we'll say a CPP file. Well, we'll make a header file. We'll just do this. We'll say this is going to be, oops, move the header up here, and we'll say this is the helper.h. And we'll put this function in helper.h. And I'm sorry, not import. Again, my Java's leaking out. Pound include string using namespace std. Oh, I need a vector here as well. And we need IO stream as well. All right, so let's see if I've broken a bunch of stuff here. So let's do a pound include helper.h, change these to be quotes. Oops. See if I can fix this in real time. So let me make sure it works before I do this. Yes, good. It's still passing. That's good. So now that I moved that over there, we can include helper.h. And so let's say as you're going off and doing your work, and you want to say contains, why doesn't this contain it, or does it contain it, or whatever's going on, maybe I can now do a C out. Or, oh no, let me see. I'm sorry, did I? In my helper, am I already printing that out? Oh, it's because I have the, I had a helper method for me to, as I was working on this, I was making sure it was working. I'd take that out. So, okay, it just changes it to a string. Yeah, that's what my intent was for it. That wouldn't be it printing out there. So I can do a C out, of toString of root. I'm sorry, of root dot to nope, not no, sorry, this toVector. There you go. That's what I want. Oops. I'll put a /n on the back of this. I forgot my parentheses. All right, so now let's see if this does what I hope it does. What did I forget? So I included helper, I included IO string, so that's good. What is it saying? Let's see. treeset.obj, what did I add that broke that? Let me just double check. Comment this line out. I don't think that's the case, but I did something to break it. It's saying toString isn't two. Maybe I don't need to do the include here. Yes, that's my issue. Now let's see if this will. Oh shoot! I thought I had to put that in there, but then it doesn't want to. Oh, maybe if I do that, then I don't need it in trees. I do not enjoy this part of C++. All right. So I was trying to do it quickly, and now I've taken a whole bunch of time because I think what I need is I need this to be this, and I need to put the implementation in a body. Let's see if that fixes my problem. Yep. Nope. Nope. What happened? Oh, missing helper. Oh, yeah. I miss Java sometimes. All right, there's much better. So I still, oh yeah, I still have some silly print there, but here you can see now it's printing out. Let me go back to my helper here. Implementation. I will clean this up before I send it off to you. But I don't need this here. But now I can, that was my debug code and I wasn't planning on there. So now you can see I can take my toString and print it out using the vector that's inside of there. So when I say could not find F, well, I can see the F is inside of there. I just simply haven't built it yet. All right. Well, there was some nice real-time solving my own problems and trying to shortcut things and do things fast, and my Java Python brain is not always ready to do C++ and follow those conventions. And they're very simple conventions, but you might be going through some of the same thing. If you've programmed in other languages, C++ might still occasionally trip you up, but it's just a matter of battling through and fixing those. But hopefully now you have an idea of how to use, you know how to build the um, the tree set behavior for uh, printing out things as a vector. And then we have the helper. We just did a real-time add to make that available for you to do some editing. And so I'll just, I'll take this, I'll republish this. So that's what you'll see the first time you see this. And that'll give you a little helper to be able to print this out as you're trying to see what's in your vector net. Now, not to say that if you have problems adding stuff in, this is going to work. You might have issues on issues of the way you're building it, but it is something you can at least see, especially once you have add working, what's going on, what the structure, what the contents of your tree is. Not the structure so much, because I don't know what the order of them are, but I could definitely see if the contents are there. It'll show you if you have extra items, or you're not deleting items, or if your item's really not even in the list because you didn't add it properly. Not the list, the tree, because you didn't add it properly. But it should help you a little bit. All right, so let's talk about some more concepts, and then we'll get going into some of the actual coding.